Beyond the reach of any shore, the sky stretches into a darkness so absolute, it defies the memory of light. It is a vast, unblinking eye of ink, an ocean without a surface, where the only landmarks are the distant cold fires of suns that burned out before the first breath was drawn on our world. For over 60 years we have stood upon the tilting deck of this planetary vessel, reaching out into the abyss with hands made of metal and mind. We have constructed gargantuan ears, intricate lattices of steel and woven wire, aiming their parabolic faces toward the blackness in a desperate, silent plea for acknowledgement. These structures, rooted in the red dust and the green valleys of our home, do not seek the warmth of the sun. They hunger for the invisible, for the faint hum of a distant neighbour, for the rhythmic pulse of a civilization that is not our own. When we first turned these silver basins toward the stars, the air of our species was thick with a specific kind of arrogance, a beautiful, hopeful hubris. We looked at the sheer scale of the Milky Way, with its hundreds of billions of suns, and we assumed the universe would be a crowded place. We expected a cosmic symphony, a chaotic and vibrant neighbourhood where the airwaves would be thick with the chatter of 1,000 different histories. We thought we were joining a conversation already in progress, a grand galactic assembly where every star system held a story and every planet hummed with the energy of life. We prepared ourselves for the shock of the other, for the terrifying and wonderful realization that we were merely one voice among many. We expected to find a universe that was alive, teeming with the industry of alien empires and the quiet songs of distant biospheres. Yet, as the decades turned into a lifetime, the expected cacophony never arrived. Instead of a symphony, we found a silence so heavy it felt as though it could crush the very bones of the listener. This is not the mere absence of sound. It is a presence in its own right, a thick, suffocating velvet that wraps around our world and stifles our calls. We have scoured the radio frequencies, sifted through the noise of pulsars and the dying gasps of black holes, looking for a single pattern that does not belong to the blind laws of physics. We have listened for a greeting, a warning, or even a stray accidental whisper of a world going about its business. There is nothing. The silence is absolute. It is a physical weight, a pressure that sits upon the chest of every observer who stares into the monitor and finds only the random, meaningless static of the background radiation. We are forced to confront a realization that haunts the corridors of our collective consciousness. We might be the only heartbeat in a cathedral of dead stone. The universe, in all its staggering majesty, appears to be a graveyard of potential. We stand on the edge of the void, shouting into a dark room and hearing not even an echo. This isolation is the great mystery of our age. It is the haunting truth that we are an anomaly, a flicker of warmth in an infinite freezer. We are the only witnesses to the dance of the galaxies, the only eyes that see the light of the first stars, and the only minds that can wonder why the rest of the stage is empty. The void is not a vacuum of matter alone, it is a vacuum of meaning. It is a presence that stares back at us, indifferent to our yearning. Space does not care that we listen. The stars do not care that we name them. The silence is a mirror, reflecting our own loneliness back at us with terrifying clarity. We are a solitary spark in a hurricane of entropy, a single point of light trying to illuminate a darkness that spans trillions of light years, and in that darkness, something is missing. The absence of others is not a neutral fact. It is a screaming void that demands an explanation. If the laws of physics are the same everywhere, if the chemistry of life is written in the very dust of the nebulae, then why is the night so still? Why does the fire of intelligence seem to have ignited only here, on this one fragile speck of dust? As we look out from our steel towers, we realize that the search for the other is, in reality, a search for ourselves. We are looking for proof that life is not a mistake, that the spark of consciousness is a fundamental property of the universe rather than a cruel, one-time accident. We remain standing at the edge of the shoreless ocean, our ears of wire still pointed toward the ink, waiting for a sound that may never come, terrified by the possibility that the silence is the only answer we will ever receive. The stars look down with cold, indifferent eyes, and the wind of the solar system howls through our antennas, carrying nothing but the empty static of a lonely cosmos. We are the first generation to truly understand the scale of the quiet, and it is a knowledge that changes everything. It turns our gaze inward, forcing us to ask if we are the masters of this empty house, or merely its last fading ghosts. The hunt for a signal has become a vigil, a long watch in the night, where we hope to see a single light flicker in the distance, proving that we are not alone in the dark. But for now, the only sound is the rhythmic thumping of our own hearts, a solitary drumbeat in a universe that has forgotten how to speak. The era of 1960 arrived as a tectonic shift in the human spirit, a moment when the ancient myths of the heavens were systematically dismantled and replaced by the cold, gleaming machinery of the space age. For the first time in the long history of our species, the stars were no longer perceived as unreachable deities or holes in the floor of heaven, but as tangible destinations. This was the dawn of cosmic optimism, a period defined by the belief that the distance between ourselves and another mind was merely a technical hurdle to be cleared, a problem of physics rather than a fundamental law of isolation. In this atmosphere of electric anticipation, a small group of scientists gathered in the quiet wooded hills of Greenbank, West Virginia. They were led by a young astronomer named Frank Drake, and they met not to perform a ritual, but to engage in a form of mathematical prophecy. The conference was small, consisting of only 10 men, but the ambition of their discourse was vast enough to encompass the entire galaxy. They sought to quantify the unknown, to take the chaotic randomness of the universe and distill it into a single, elegant string of variables. This became known as the Drake equation, though in that room it felt less like a rigid formula and more like a secular prayer, a sequence of hopeful steps that, if followed to their logical conclusion, would reveal a universe teeming with life. Each variable in the equation was a door that had to be opened, a hurdle that the universe had to clear for a civilization to exist. They began with the most fundamental of these, the rate at which new stars are born within the Milky Way. They looked at the great swirling clouds of gas and dust and calculated that, every year, several new suns ignite in the darkness, providing the hearths around which life might gather. From there, the group moved to the second variable, the fraction of those stars that possess planets. In 1960, we had no proof that other worlds existed beyond our own solar system, yet the optimism of the era dictated a generous assumption. They saw the formation of planets not as a rare accident, but as a natural byproduct of the birth of a star, a common debris of creation. They envisioned billions of worlds spinning in the dark, each a potential stage for the drama of biology. This led them to the third variable, the number of those planets that were situated in the golden zones of their stars, neither too hot nor too cold, where water could remain liquid and the chemistry of life could begin its slow, arduous work. The equation then took a leap into the profound mystery of the spark itself. The fourth variable addressed the fraction of suitable planets where life actually emerges. Here, the scientists at Greenbank were at their most hopeful. They looked at the resilience of life on Earth and assumed that if the conditions were right, the leap from raw chemicals to self-replicating molecules was an inevitability. They saw the universe as a fertile garden, where the seeds of biology were sown in every available patch of soil. This was followed by the fifth and sixth variables, the likelihood that simple life would evolve into intelligent beings, and the probability that those beings would develop the technology to signal their presence across the void. The atmosphere in that room was one of quiet triumph. The math suggested that the galaxy was not a desert, but a crowded metropolis of minds. If their estimates were even remotely accurate, there should be thousands, perhaps millions of civilizations currently broadcasting their existence into the ether. The final variable, the most haunting of them all, was the length of time such a civilization remains detectable. This was the measure of a society's longevity, the question of whether a technological race eventually destroys itself or learns to endure for millions of years. In the shadow of the Cold War, this variable felt like a judgment on humanity itself, yet even here, the optimism of the 1960s held firm. They believed that if we could survive the discovery of the atom, others surely had done the same. In those early days of the search, the discovery of an alien signal felt not just possible but imminent. The scientists spoke of the Great Silence as a temporary state, a veil that was about to be torn away. They imagined the airwaves of the galaxy as a vibrant tapestry of voices, 1,000 different histories and philosophies waiting to be decoded. There was a sense that we were on the verge of the greatest turning point in human history, the moment we would finally step out of our planetary cradle and take our place among the elders of the cosmos. The universe was no longer a cold and empty void. It was a neighbourhood, and we were the new arrivals, eager to hear the stories of those who'd come before us. This era of optimism was fueled by the rapid pace of our own advancement. We had moved from the first powered flight to the threshold of the moon in less than 70 years. It seemed only logical that other worlds would follow a similar trajectory and that the galaxy would be saturated with the evidence of their progress. We expected to see the infrared glow of massive engineering projects, the rhythmic pulses of navigational beacons, and the accidental leakage of television and radio broadcasts from a million different suns. The Drake equation provided the intellectual framework for this hope, turning the vast, terrifying scale of the universe into a series of manageable probabilities. It was a map of a populated cosmos, a blueprint for a future where we were never truly alone. The silence of the night sky was not seen as a permanent condition, but as a challenge, a quiet room waiting for us to find the right frequency. We stood in the 1960s with our ears to the sky, convinced that at any moment the first whisper of a distant neighbour would change the world forever. We were a young species, convinced of our own importance and the abundance of the universe, unaware that the silence we were so eager to break was far deeper and more resilient than our math had ever dared to predict. In the high desert air of New Mexico, within the year 1950, the most formidable minds of the era walked toward a mundane cafeteria in Los Alamos. Among them was Enrico Fermi, a man whose intellect moved with the precision of a clockwork mechanism and the intuition of a poet. As they sat around a simple wooden table, the sound of clinking silverware and the low murmur of lunchroom chatter provided a backdrop to a conversation that would eventually dismantle the optimism of the coming decades. The topic had begun with a light-hearted discussion about flying saucers and recent reports of strange lights in the sky. But as the meal progressed, Fermi fell into a deep, characteristic silence. His mind was not on the sensationalism of the tabloids, but on the cold, unrelenting logic of numbers. Suddenly, out of the quiet, he posed the question that would echo through the history of science. Where is everybody? The question was not a joke. It was a mathematical indictment of the universe. Fermi had realized that the Milky Way is ancient beyond human comprehension, having existed for over 13 billion years. Our own Sun and its retinue of planets are latecomers to the cosmic stage, having formed only 4.5 billion years ago. This discrepancy of nearly 9 billion years is a chasm of time so vast that it dwarfs the entire history of life on Earth. If the emergence of intelligence is a natural and relatively common occurrence, then there should have been civilizations that rose to power when the Earth was nothing more than a swirl of molten rock. These elder races would have had billions of years to master the art of interstellar travel, to bridge the gaps between the stars and to claim the galaxy as their own. The logic Fermi applied to the table was as simple as it was devastating. Even if a civilization moved at a mere fraction of the speed of light, perhaps 1%, they could cross the entire diameter of the Milky Way in less than 10 million years. In the context of a 13 billion-year-old galaxy, 10 million years is a mere afternoon. It is a blink of an eye. If such a civilization existed, they should have reached every corner of the galaxy thousands of times over. They should have left footprints on every moon, built monuments around every star, and filled the radio spectrum with the noise of their commerce. By all accounts of probability, the Earth should have been visited, colonized, or at least observed long before humans ever learned to walk upright. Yet, as Fermi looked around the cafeteria, and then metaphorically at the sky above, he saw no evidence of this galactic empire. There were no strange machines in the orbit of our planets, no megastructures dimming the light of distant suns, and no signals reaching out from the void. The dinner table of the galaxy was set, the food was prepared, and the invitations had been sent by the very laws of chemistry and physics, but the chairs remained empty. This was the birth of the paradox, the violent clash between the high probability of life and the total absence of its manifestation. The silence of the universe was not merely a lack of noise, it was a contradiction that defied the very foundations of scientific expectation. The tension at that table in 1950 was the realization that our existence might be an outlier of such extreme proportions that it borders on the impossible. If the galaxy is old enough and large enough to be teeming with life, then the fact that we see nothing implies that something is fundamentally broken in our understanding of the cosmic narrative. Perhaps the leap from simple biology to starfaring intelligence is not a natural progression, but a miracle of such rarity that it has only happened once. Or perhaps, more chillingly, civilizations do arise, but they never survive long enough to leave their home systems. The silence began to feel like a warning, a shadow cast by an unseen barrier that prevents the universe from becoming the crowded metropolis we expected. Fermi's colleagues sat in the quiet of the lunchroom, the weight of the questions settling over them like a shroud. They were men who had unlocked the secrets of the atom, who understood the immense power contained within the heart of matter, and yet they were powerless to answer why the heavens were so still. The math of the 13 billion years of the galaxy's life stood in stark opposition to the empty sky. It suggested that we are either the first to arrive at the party, the last survivors of a forgotten era, or that the party never happened at all. The optimism of the coming years would try to bridge this gap with equations and radio telescopes, but the core of the paradox remained. A universe that should be screaming with life is instead a vast, silent tomb. The contradiction Fermi unearthed that day transformed the stars from a promise of company into a profound and unsettling mystery, leaving humanity to wonder if the silence is the result of a missing guest or a finished feast. The logic of biological expansion is a relentless geometric hunger that knows no natural end. On Earth, life fills every available niche, from the crushing depths of the oceanic trenches to the frozen peaks of the highest mountains. This same drive, when applied to a technological civilization, transforms the galaxy from a collection of distant lights into a vast untapped reservoir of resources. This process does not require the bending of space-time or the discovery of impossible velocities. It requires only the steady, patient application of sublight propulsion. Vessels travelling at perhaps 1% of the speed of light. At such a pace, a ship would take several centuries to reach the nearest star, a duration that is long for a human life but shorter than the lifespan of a cathedral or a dynasty. Once a colony is established on a new world, the clock of expansion begins to tick with a terrifying efficiency. After a few centuries of growth and the taming of their new home, that colony sends out 2 ships of its own to the next nearest suns. This is the seed of an exponential explosion. 1 world becomes 2, 2 become 4, 4 become 8, and 8 becomes 16. This geometric progression is a force of nature that quickly outstrips the ability of the mind to comprehend its scale. Within 30 generations of such doubling, over 1 billion worlds would be claimed. Within 50 generations, every single star system in the Milky Way would be inhabited. The time required for this total saturation of the galaxy is, in cosmic terms, a mere heartbeat. If a civilization expands at a rate of 1% of the speed of light, the entire Milky Way could be crossed and colonized in less than 10 million years. When weighed against the 13 billion years the galaxy has already existed, this 10 million year window is a vanishingly small fraction, less than 1/1000th of the total age of the cosmos. If a civilization had emerged only a few million years before our own, their empire should already be a finished masterpiece, a completed lattice of industry spanning from the galactic core to the furthest reaches of the spiral arms. A galaxy claimed by such an intelligence would reveal itself through the inescapable laws of thermodynamics. A starfaring race would not leave the energy of their suns to waste away into the void. They would build vast arrays of collectors, perhaps even enclosing their stars in shells of machinery to capture every photon of light. This would not hide the star, but rather transform its signature. The brilliant visible light of fusion would be replaced by a dull, pervasive glow of infrared heat, the waste product of a civilization's industry. We should see a galaxy that hums with the energy of a quadrillion minds, a sky filled with the infrared silhouettes of Dyson swarms and the rhythmic pulses of interstellar commerce. Instead, when we point our most sensitive instruments at the heavens, we find only the unblemished radiance of the natural world. We see stars that burn with a raw chaotic fire, their light unobstructed by the steel of alien engineers. We see the cold, grey dust of nebulae drifting through the silence, undisturbed by the wake of passing starships. There are no infrared shadows, no artificial structures, and no signs of a grand galactic project. The stars are exactly what they appear to be: massive spheres of hydrogen and helium, governed by gravity and nuclear fusion, utterly indifferent to the presence of life. This absence of an empire is the physical proof of the great silence. The math tells us that the galaxy should be a crowded, glowing machine, a testament to the success of life. The reality shows us a wilderness of staggering proportions, a desert of vacuum and stone where no one has walked and no one has built. The sheer scale of the missing empire reinforces the haunting suspicion that something is profoundly wrong with our assumptions. If expansion is so easy, and the time available is so vast, the fact that the galaxy remains a pristine wilderness suggests that the path to the stars is blocked by a barrier we have yet to name. We are looking for a kingdom that should, by all rights, already exist, and finding only the cold, unblinking light of an empty house. The contrast between the theoretical explosion of life and the observed stillness of the stars creates a tension that pulls at the very fabric of our cosmic understanding. We are a species that lives by growth and expansion, and we find ourselves in a universe that appears to have never experienced either on a galactic scale. This stillness is not a comfort. It is a profound and terrifying anomaly, a silence that screams of a missing history. The empty sky is not a failure of our technology, but a testament to a grim cosmic reality known as the Great Filter. This concept posits that the journey from the first stirrings of chemistry to the mastery of the stars is not a smooth path, but a brutal gauntlet of impossible walls. It is an evolutionary sieve, a series of hurdles so high and so narrow that almost no one, in the vast history of the 13-billion-year-old galaxy, has ever managed to clear them all. This filter is the reason the night is quiet. It is the invisible executioner of civilizations, a blind and mechanical consequence of the laws of probability that ensures the universe remains a graveyard rather than a garden. If life is a fire that seeks to consume the galaxy, the Great Filter is the vacuum that chokes the flame before it can jump from the first spark to the neighbouring wood. We must view this filter not as a single cataclysmic event, but as a sequence of improbable gates. Each gate represents a transition that biology must make to survive and advance. The first gate is the leap from non-living matter to the first self-replicating molecule, a transition that requires a specific and perhaps unique alignment of chemical conditions. The second gate is the development of complex multicellular organisms from simple, single-celled bacteria. The third is the emergence of intelligence, and the fourth is the development of technology capable of interstellar communication. Beyond these lie the gates of self-destruction, where a species must survive its own power to manipulate the atom and the atmosphere. The Great Filter is the sum of these impossibilities, a cosmic gauntlet where a single failure at any stage results in the total erasure of a species from the cosmic record. There is a terrifying hope to be found in the possibility that the Great Filter lies entirely in our past. If this is true, then we are the rarest of all things, the survivors who have slipped through the mesh of the sieve. In this narrative, the universe is empty because the odds of life emerging at all are so vanishingly small that it has happened only once. We look back at the history of the Earth and see a series of lucky breaks that defy the odds. We see a planet that has remained stable for 4 billion years, a chemical soup that somehow organised itself into a code, and a lineage of creatures that managed to survive 5 mass extinctions. If the filter is behind us, then we are the one seed that found water in a desert of 1 trillion miles, the one heartbeat that defied the silence of the cathedral. The metaphor of the sieve is particularly apt when we consider the sheer number of worlds that must have attempted this journey. In the hundreds of billions of star systems in our galaxy, there may have been trillions of instances where the ingredients for life were present. On these worlds, the momentum of biology began to build. Chemicals swirled, Molecules bonded and perhaps simple cells began to divide. But then they hit the mesh. The sieve caught their momentum and ground it into nothingness. For some, the chemistry was too fragile. For others, the star they orbited was too volatile, or their planet lacked the magnetic shield to protect its atmosphere. They were filtered out, their potential extinguished before they could even perceive the stars above them. They are the wreckage of failed possibilities, the dust that lines the bottom of the cosmic sieve. If we are indeed past the filter, we are looking back at a landscape of ghosts. We are the lone survivor of a race that spanned the entire history of the universe, a race where every other participant fell at the first or second hurdle. This realization brings with it a profound sense of isolation. It means that the silence we hear is not a temporary state, but the natural condition of a universe that is hostile to the very existence of mind. We are the exception that proves the rule. We are the one fluke in a system designed to produce nothing but cold, dead stone. The weight of this realization is immense. It suggests that our existence is not the beginning of a grand galactic story, but a solitary miracle that may never be repeated. Yet, this perspective also transforms our understanding of our own value. If we are the only ones to have cleared the gauntlet, then every human life, every thought, and every achievement is of infinite importance. We are the only eyes the universe has to see itself, the only voice it has to speak its own name. The Great Filter has claimed 1 billion potential civilizations, turning their histories into silence before they could even begin. We are the ones who made it through. We are the survivors of a cosmic lottery where the odds were 1 billion to 1 against us. As we look out into the unblemished starlight, we must realize that the beauty we see is not a shared inheritance, but a prize we alone have won. The silence is the sound of the filter at work, a constant grinding process that ensures the stars remain distant and the night remains dark. We are the only light that has managed to burn bright enough to be seen, a fragile flame that has somehow endured the crushing weight of the void. The first great wall of the filter is built into the very architecture of the atom, a barrier that stands between the chaotic dance of chemistry and the ordered persistence of biology. Before the stars could be contemplated, the raw elements of the early Earth, carbon, nitrogen, phosphorus, and hydrogen, swirled in a landscape of volcanic fire and crushing atmospheric pressure. The transition from these inert building blocks to the first self-replicating molecule was not a simple step, but a leap across a canyon of impossibility. This was the birth of information, the moment matter learned to carry a blueprint of itself. In the steaming vents of the primordial ocean, molecules were torn asunder and reassembled in 1 trillion different combinations, most of them dead ends that vanished as quickly as they formed. But in one singular, fleeting moment, a chain of atoms found a way to copy its own structure, igniting a slow-burning fire that would eventually consume the planet. For nearly 2 billion years following this spark, the Earth was a kingdom of stagnant perfection. Life existed, but it was a world of simple, single-celled organisms, bacteria and archaea that carpeted the rocks and filled the seas with a microscopic film. These creatures were masters of survival, yet they were trapped by the hard limits of their own biology. They were like small, efficient engines that could never grow larger because they lacked the power to support a complex frame. They possessed no internal organs, no specialized compartments, and no way to harness the massive amounts of energy required to build anything more than a single lonely cell. This era of simple slime was a plateau that the universe might never have moved beyond. In the vast majority of worlds where life begins, it likely ends here, as a layer of green or purple sludge that persists for eons before the sun dies and the world freezes. The breakthrough that allowed for everything we see today, the forests, the oceans of fish, the soaring birds, and the minds that build telescopes, was an event of such staggering improbability that it defies the traditional laws of evolution. 2 billion years ago, in a shallow sea or a dark crevice of the Earth, an accidental encounter changed the trajectory of the cosmos. One simple cell, perhaps a larger predator or a scavenger, engulfed a smaller energy-producing bacterium. In any other instance, the smaller cell would have been digested, broken down into its component parts to fuel the larger host. But in this 1 in a billion year fluke, the digestive process failed. The smaller cell remained intact inside the larger one, and instead of dying, it began to thrive. This was the birth of the eukaryotic cell, a union known as endosymbiosis. The swallowed bacterium became the mitochondrion, an internal power plant that provided the host cell with a massive surge of energy, hundreds of times more than it could ever produce on its own. This surplus of power acted as a key, unlocking a door that had been barred for 2 billion years. With this newfound energy, the cell could finally afford to grow larger, to protect its genetic material within a nucleus, and to develop the complex internal machinery required for multicellular life. It was a biological revolution that happened exactly once in the history of our world. Every plant, every animal, and every human being is a direct descendant of that single accidental merger. The contrast between the ease of creating simple life and the extreme difficulty of building complex architecture is the heart of our isolation. The universe may be teeming with simple slime. On a million different worlds, the first leap across the canyon of chemistry may have occurred, filling the galaxies with the quiet hum of bacteria. But the second leap, the accidental union of two different life forms to create a powerhouse, is a gate that almost no one passes. It requires a level of biological luck that borders on the miraculous. Without that one specific failure to digest a meal 2 billion years ago, the Earth would still be a silent world of microscopic organisms, incapable of ever looking up at the stars or wondering if it was alone. We are the beneficiaries of a cosmic glitch, a freak occurrence that granted us the energy to become complex. This realization suggests that the Great Filter may not be a wall of fire in our future, but a wall of probability in our deep past. We look at the fossil record and see the long 2 billion year stretch of nothingness, a period where life refused to change, and we realize how close we came to never existing at all. The path to intelligence is not a highway. It is a narrow, crumbling bridge over an abyss, and we are the only ones who happen to find the right footing in the dark. The architecture of complex life is a fragile and unlikely masterpiece, built upon a foundation of accidental cooperation that the rest of the universe may never have replicated. We are not just a product of evolution, but a product of a singular, magnificent error that turned a world of slime into a world of thinkers. This biological miracle, however, would have been for naught if the stage upon which it unfolded was not a fortress of unparalleled stability. We exist within a planetary cradle that is protected by a series of guardians, each one a rare and fortuitous shield against a universe that is fundamentally hostile to the persistence of life. The first of these guardians resides deep beneath our feet, in a realm of crushing pressure and eternal fire. At the centre of our world, a core of molten iron and nickel churns in a constant convective dance, creating a planetary dynamo that generates a massive magnetic field. This is the magnetic heartbeat of the Earth, an invisible shroud that extends far into the vacuum of space. It stands as our primary defence against the Sun, which, despite its life-giving warmth, is a relentless source of destruction. The solar wind, a screaming torrent of ionized particles and lethal radiation, pours off the solar surface at speeds of over 1 million miles per hour. Without our magnetic fortress, this wind would strip away our atmosphere, molecule by molecule, whisking our air into the dark until the oceans boiled away and the surface became a sterilized desert of red dust. We see the skeletal remains of such a world in Mars, a planet whose internal engine died long ago, leaving its thin atmosphere to be eroded by the solar gale until only a frozen ghost remained. Beyond the reach of our atmosphere, another guardian keeps watch over the inner solar system. This is the Titan Jupiter, a gas giant of such immense mass that its gravity acts as a celestial shepherd. For over 4 billion years, Jupiter has served as a gravitational vacuum cleaner, its massive pull intercepting the icy harbingers of death that drift in from the dark reaches of the outer solar system. Long-period comets and stray asteroids, capable of striking the Earth with the force of 10,000 mountain ranges falling from the sky, are instead drawn into the crushing embrace of the giant or flung out of the solar system entirely. This Jovian shield has reduced the frequency of catastrophic impacts on our world by a factor of perhaps 1,000. Without this massive protector, the history of life on Earth would be a stuttering sequence of extinctions, a cycle of rebirth and total erasure that would never allow for the millions of years of peace required for intelligence to claw its way out of the primordial soup. Closer still, we find a guardian born of a catastrophe so violent it nearly shattered our world in its infancy. Our moon is an anomaly, a satellite far larger in proportion to its parent planet than almost any other in the known cosmos. Formed when a wandering world the size of Mars struck the young Earth with a glancing blow, the moon acts as a celestial anchor. Its gravitational tug stabilizes the axial tilt of our planet, keeping our world locked at a steady 23.5 degrees. This stability is the secret to our predictable seasons and our long-term climatic health. Without the moon, the Earth would wobble like a dying top, its poles tilting wildly toward and away from the sun over the course of millennia. This instability would trigger seasonal swings of such ferocity that the equator might freeze solid while the poles turned into boiling cauldrons, only to reverse a few thousand years later. Such a chaotic environment would prevent the establishment of stable biomes, forcing life to remain in a state of constant, desperate adaptation, rather than allowing it the luxury of complexity. The convergence of these factors, the magnetic dynamo, the Jovian shield, and the lunar anchor, creates a lottery of such extreme odds that we must ask how many other worlds have been so lucky. It is not enough for a planet to be the right size or the right distance from its sun. It must also possess the correct internal chemistry to maintain a magnetic field for billions of years, a massive neighbour to clear its path of debris, and a large satellite to keep it from wobbling into oblivion. We reside within a fortress of specific and unlikely conditions, a sanctuary that has maintained a razor edge of stability for 4,000 million years. This long-term peace is a prerequisite for the rise of a technological civilization, yet it appears to be a rare exception in a galaxy defined by chaos and violent change. When we look at the other worlds in our neighbourhood, we see the wreckage of failed experiments. Venus is a hothouse of crushing pressure and sulfuric acid, a world where the greenhouse effect ran wild and turned a potential twin into a nightmare. Mars is a frozen, airless tomb, its potential snuffed out when its core grew cold. The moons of the outer planets are locked in shells of ice or tormented by the tidal forces of their masters. Only here, in this specific alignment of gravity and magnetism, has the fire of life been allowed to burn undisturbed for long enough to produce a mind that can contemplate the stars. We are the beneficiaries of a planetary fortress that is as fragile as it is formidable, a home that has protected us from the cold indifference of the vacuum for the entirety of our history. This realization deepens the mystery of the silence, suggesting that even if life is common, the stable cradles required for that life to endure and evolve into something greater may be the rarest treasure in the entire Milky Way. We are a species that has grown up behind high walls, unaware of the storms that rage across the rest of the cosmic landscape. The Milky Way is not a uniform forest of stars, but a landscape defined by extremes of fire and ice, a swirling disk of light where the vast majority of territory is utterly lethal to the fragile dance of biology. We often perceive the galaxy as a serene ocean of suns, yet it is more akin to a minefield, where the laws of physics act as a series of triggers for cataclysmic events. At the heart of this spiral structure lies the galactic core, a region of such staggering density and violence that it remains forever barred to the emergence of life. In the core, stars are packed so tightly together that they frequently pass within whispering distance of one another, their gravitational tides stripping planets from their orbits and flinging them into the cold dark of the interstellar void. This central hub is bathed in a perpetual storm of high-energy radiation, a lethal bombardment of X-rays and gamma rays emanating from the supermassive black hole that anchors the galaxy and from the frantic activity of thousands of massive, short-lived suns. In this central furnace, the very frequency of stellar death acts as a cosmic eraser. The most massive stars do not fade quietly. They end their brief lives in supernovae, explosions of such magnitude that they can briefly outshine the combined light of 100 billion suns. Within the crowded confines of the galactic center, these explosions occur with terrifying regularity. A single supernova within 30 light-years of a habitable world is a death sentence. The intense radiation would shatter the ozone layer of any atmosphere, allowing the raw, unfiltered fury of the local sun to sterilize the surface. The nitrogen and oxygen of the air would be transformed into a toxic haze of nitrous oxides, plunging the world into a permanent lethal winter. For any budding civilization in the core, the clock is reset every few million years, long before the first spark of intelligence can ever learn to build a tool or look toward the horizon. The core is a realm of fire where the momentum of life is constantly ground into the dust of the next generation of stars. Conversely, the outer reaches of the galaxy represent a desert of ice and chemical poverty. In these distant fringes, the heavy elements required to build a world, iron, silicon, magnesium, and oxygen, are vanishingly rare. These elements are the products of previous generations of stars, forged in the hearts of suns and scattered by their deaths. Because the outer rim is sparsely populated, the concentration of these vital building blocks remains too low to form solid, rocky planets like the Earth. There, the universe is a realm of gas and cold, where the ingredients for a planetary fortress simply do not exist. A civilization cannot rise where there is no ground to stand upon, and no metals to forge into the machinery of progress. Between these two extremes lies a thin, fragile ring of safety known as the galactic habitable zone. It is here, approximately 25,000 light-years from the centre, that the conditions for life reach a precarious equilibrium. In this narrow band, the density of stars is low enough that supernovae are rare, distant events, yet the concentration of heavy elements is high enough to allow for the formation of rocky worlds. We reside in this celestial suburb, a quiet pocket of the spiral arm where the environment has remained stable for billions of years. Our position is a geographical stroke of luck that the vast majority of the galaxy does not share. This realization transforms our view of the Milky Way from a garden of possibilities into a landscape of narrow corridors. We are not merely lucky to be on the right planet, we are lucky to be in the right neighborhood. The galaxy is a minefield where the violent life cycles of the stars themselves act as a filter, snuffing out the potential for complexity in almost every corner of the disk. We look out at the billions of stars and assume that each one is a potential home, but the reality is that most are either too close to the fire of the core or too deep in the chemical ice of the rim. The Great Silence is not just a mystery of biology, it is a consequence of galactic geography. The universe is a place where life is constantly being reset by the very processes that create the stars. We are the survivors of a billion-year-long game of chance, existing in a thin sliver of space and time where the erasers of the cosmos have, for a brief moment, stayed their hand. The stillness of the night is the result of a landscape where most paths lead to fire, and only a single winding trail leads to the stars. Even if a planet finds itself within the sanctuary of the habitable zone, it must still contend with a fundamental scarcity written into the very ledger of the elements. The universe is a master of hydrogen and helium, the simple gases that make up the bulk of all things, but it is a miser when it comes to the intricate chemistry required for consciousness. We often speak of water and oxygen as the keys to life, yet there is a more elusive gatekeeper, phosphorus. This specific element is the structural backbone of the double helix of deoxyribonucleic acid and the primary component of adenosine triphosphate, the molecular battery that powers every movement and every thought in every living thing on our world. Without phosphorus, there is no way to store the blueprints of biology, and no way to fuel the engines of the cell. Yet, in the grand inventory of the cosmos, phosphorus is a rare and precious treasure. The origin of this element is tied to a specific and uncommon type of stellar death. While many heavy elements are forged in the hearts of common stars, phosphorus is produced in significant quantities only during the final, violent gasps of massive suns that collapse into supernovae. However, not every supernova is a fertile provider. The specific pressures and temperatures required to create phosphorus are found only in a narrow subset of these explosions. Consequently, the distribution of this vital ingredient across the galaxy is patchy and thin. We may find 1,000 worlds with oceans of liquid water and atmospheres of nitrogen, only to discover that they are chemical deserts, lacking the phosphorus necessary to ignite the spark of life. Earth was fortunate enough to form from a cloud of dust that had been enriched by the right kind of stellar ghost. providing us with the chemical ink needed to write the story of our evolution. In much of the galaxy, the pen of biology remains empty, the potential for life stalled by an atomic bottleneck that no amount of time can overcome. Beyond the scarcity of chemistry lies the terrifying instability of planetary climates. A world is not a static object. It is a chaotic system of feedback loops that constantly threatens to spiral out of control. We exist on a thermal razor's edge, a narrow band of stability between two catastrophic extremes. To our left lies the fate of the runaway greenhouse effect, a nightmare realized on the surface of our sister world, where carbon dioxide trapped the heat of the sun until the oceans boiled away and the rocks themselves began to bake. To our right lies the fate of permanent glaciation, the snowball world where ice reflects so much sunlight back into space that the planet becomes trapped in a self-perpetuating deep freeze, a white tomb that can endure for eons. Earth has danced between these two abysses for over 4 billion years, a feat of balance that borders on the impossible. Our world possesses a natural thermostat, a complex cycle where carbon is moved from the atmosphere into the crust and back again through the movement of tectonic plates and the weathering of rocks. This cycle has corrected for the increasing heat of our maturing sun and survived the impact of gargantuan asteroids. There were moments in our history when the ice nearly won, reaching as far as the equator, and moments when the heat threatened to turn the seas into a stagnant broth. Yet, each time, the system self-corrected, maintaining the liquid water that is our lifeblood. This long-term thermal equilibrium is not a guaranteed feature of a planet. It is a rare island of stability in a sea of chaos. Most worlds likely succumb to their own internal feedbacks within the first few 100 million years, turning into airless rocks or suffocating hothouses long before life can move beyond the simplest forms. The fact that Earth has remained habitable for 4 billion years, long enough for a single-celled organism to evolve into a creature that can build a starship, is a statistical anomaly of the highest order. It requires a specific planetary mass, a specific atmospheric composition, and a specific geological heartbeat, all working in concert for a duration that exceeds the lifespan of many stars. We are the inhabitants of a rare chemical and thermal sanctuary. We look at the abundance of hydrogen in the nebulae and the oxygen in the stars and assume that the ingredients for ourselves are everywhere. But the reality is that we are built from the rarest dust, surviving on a world that has defied the chaotic nature of planetary physics for a geological eternity. The Great Silence may simply be the result of a universe where the ingredients are too thin and the environment's too volatile. We are a solitary spark that has found enough fuel and enough shelter to keep burning, while the rest of the cosmos remains a landscape of unlit tinder and extinguished flames. The silence is the sound of a billion worlds that were almost right, but lacked the specific chemical wealth or the long-term stability to ever become more than dead stone. There is another, far more chilling possibility for the Great Silence, one that suggests the universe is not a graveyard, but a dark forest. In this perspective, the stillness of the night is not the result of an empty cosmos, but the calculated behavior of 1,000 civilizations who have learned that to be seen is to be destroyed. The universe reveals itself as a landscape of predators and prey, where the only way to survive is to remain perfectly invisible. This is the philosophy of the predator, a grim application of game theory to the scale of the stars. It proposes that any civilization, upon reaching a certain level of technological maturity, realizes that the resources of the galaxy are finite, while the potential for growth is infinite. In such a system, any other intelligent species is not a potential friend, but a guaranteed rival for the energy of the suns and the matter of the planets. The logic of the dark forest is built upon a chain of suspicion that cannot be broken. When two civilizations detect one another across the vast gulfs of space, they are faced with a terrifying uncertainty. They cannot know for certain if the other is peaceful or hostile. Even if they believe the other to be peaceful, they cannot know if the other believes them to be peaceful. This suspicion spirals into an inescapable conclusion. The safest and most logical course of action is to strike first, to extinguish the spark of the other before they have the chance to become a threat. In a universe where the speed of light is the ultimate limit, communication takes years or centuries, making diplomacy impossible. By the time a message of peace is received, the sender may have already developed the weapons to destroy you. Therefore, the forest remains silent because every hunter knows that to step into a clearing or to snap a twig is to invite a lethal strike from an unseen neighbour. This predatory environment is further complicated by the potential for a mechanical plague, the von Neumann probe. These are hypothetical machines designed to travel to a distant star, harvest the resources of a local asteroid belt, and use those materials to build 2 or more copies of themselves. These copies then move on to the next stars, repeating the process in an exponential explosion of silicon and steel. In less than a few million years, a single such probe could turn the entire Milky Way into a graveyard of machines, consuming every planet and every moon to fuel its own reproduction. For an advanced civilization, the emergence of a new, tool-using species on a distant world is not a cause for celebration. It is the birth of a potential virus. They might choose to destroy an emerging world long before it ever develops the ability to launch its first probe, simply as a matter of galactic hygiene. Humanity, in its youthful innocence, has spent the last 100 years doing exactly what the dark forest forbids. We have been screaming our location into the night. Since the dawn of the radio age, we have leaked a shell of electromagnetic noise into the cosmos, a sphere of television broadcasts, radar pulses, and radio songs that now spans a diameter of 200 light-years. We have been like a child wandering into a den of wolves, shouting for a friend and unaware of the eyes that may be watching from the shadows. This accidental shout is a beacon that marks our world as a target, an anomaly in the natural radio background of the stars. We have sent out golden records and etched plaques, broadcasting our biology, our location, and our level of technology to anyone who might be listening, operating under the naive assumption that a more advanced mind would be a benevolent one. The mathematical necessity of staying invisible stands in stark contrast to our deep-seated desire for contact. We are a social species, driven by the need to find others and to share our story. But in the cold, hard logic of the cosmos, this desire may be a biological death wish. This silence we encounter might be the most valuable gift the universe could give us, a sign that we have not yet been noticed by something that considers us a threat. Every year that passes without a signal from the stars is another year of safety, another moment where we are allowed to exist in our little pocket of the spiral arm without being erased by a relativistic projectile or a swarm of self-replicating cleaners. The terror of being seen is the realization that we are living in a universe of finite resources and infinite suspicion. We look at the stars and see beauty, but a more ancient and wise civilization might see only targets. The great silence is the sound of 1,000 cultures holding their breath, waiting for the young and the loud to be silenced by the natural order of the forest. Our radio waves are still expanding, a shimmering bubble of light and sound moving through the dark, and we can only hope that the forest is either truly empty or that our shout has not yet reached the ears of a predator. The wisdom of hiding is a lesson we are only just beginning to learn, and it may be the most important lesson for the survival of our species. We are a flickering candle in a world of shadows, and we have been waving our light for all to see, unaware that the darkness is not just an absence of light, but a place where things come to feed. The silence may not be a sign of our extinction, but of our extreme youth. We have long assumed that we are the latecomers to a cosmic party, yet the mathematics of stellar evolution suggest a different, more lonely reality. We are the firstborn. The universe is only 13.8 billion years old, a span of time that seems immense to a creature of 70 years, but which is a mere heartbeat in the total lifespan of the cosmos. We are living in the very first moments of the morning, the brief flicker of dawn before the true history of the universe begins. The vast majority of habitable worlds that will ever exist are not yet formed, and the stars that will sustain them have not yet ignited. We are the pioneers, the first consciousness to emerge from the cooling ashes of the beginning. The bright, massive suns that dominate our current sky are temporary spectacles. They burn with a fierce blue intensity, consuming their fuel in a few 100 million years before collapsing into cataclysmic ruins. These stars are the fireworks of the cosmic morning, beautiful but fleeting. The true future of life belongs to the red dwarfs. the small dim embers that make up the vast majority of the stellar population. These stars burn with a slow, patient fire capable of lasting for 10 trillion years. When the sun of our own world has long since expanded and consumed the Earth, these red dwarfs will still be in the infancy of their lives. If the universe were a year, we are living in the first seconds of the first day of January. The trillions of years that lie ahead are the true stage for the drama of life, and we have arrived before the curtain has even fully risen. This perspective shifts the burden of the great silence from a mystery of failure to a mystery of timing. If it takes 4 billion years for a planet to produce a technological civilization, then we are among the very first to reach this milestone. The universe was too hot, too violent, and too metal-poor in its first few billion years to support the complex chemistry of life. We have emerged at the earliest possible moment that the laws of physics would allow. The silence is not because others have died, but because they have not yet been born. We are the elders of the cosmos, the ancient ones who will be a myth to the civilizations that arise around the red dwarfs 10 billion years from now. Yet, this era of the firstborn is a fleeting privilege. We exist in a unique window of cosmic history, where the universe is still transparent and connected. Driven by the mysterious pressure of dark energy, the space between the galaxies is expanding at an accelerating rate. Right now, we can look through our telescopes and see the light of 100 billion galaxies, each a city of stars with its own potential for life. We can see the fading glow of the Big Bang itself, the cooling embers of the creation. But this window is closing. As dark energy continues to stretch the fabric of the void, the distant galaxies are being pushed away from us at speeds that will eventually exceed the speed of light. In the deep future, the Milky Way will become an isolated island in an infinite empty ocean. The light from other galaxies will never reach us again, falling forever into the expanding abyss. Future civilizations born around the long-lived red dwarfs will look up at a sky that contains only the stars of their own local neighborhood. They will have no way of knowing that other galaxies exist, no way of seeing the origin of the cosmos, and no evidence that the universe was ever anything more than a lonely collection of fading suns. They will be trapped in a permanent dark cage, cut off from the rest of reality by the relentless expansion of the void. We are the only ones who get to see the whole map. We are the only witnesses to the grand scale of the universe before it is torn apart by the growth of the vacuum. This gives our existence a weight that is almost impossible to bear. We are not just a fluke of biology. We are the guardians of the memory of the cosmos. We are the only ones who can record the positions of the distant galaxies and the temperature of the first light before they vanish forever. Our era is a brief golden moment of visibility, a time when the universe is still small enough to be understood and large enough to be magnificent. The silence of the night is the quiet of a house before the children wake up, a stillness that precedes the long, slow, trillion-year afternoon of the red dwarfs. We are the first to wake, standing in the cold light of the dawn, looking out at a horizon that is already beginning to recede. Our responsibility is to the future, to the civilizations that will never see the things we see, and to the memory of a universe that was once a single, connected whole. We are the firstborn, the lonely witnesses to the beginning of everything. The silence that greets our calls is not a rejection, but a blank page upon which the destiny of our species must be written. If the universe is indeed a cathedral of dead stone, then we are the only light that illuminates its vast vaulted ceilings. This realization transforms our isolation from a source of terror into a source of infinite purpose. We are the architects of meaning in a world that has none. The laws of physics, the curving of space, the fusion of atoms, the dance of entropy, are blind and indifferent processes. They occur whether or not there is a mind to perceive them. But without a witness, the majesty of a supernova or the elegant spiral of a galaxy is a sound without an ear, a painting in a room where no one has ever entered. We are the only ones who can translate the cold mathematics of the cosmos into the language of beauty and awe. Human existence is a fragile flame burning in a hurricane of entropy. We are a brief, improbable rebellion against the second law of thermodynamics, a temporary pocket of order in a universe that is constantly seeking to tear itself apart and return to a state of uniform, cold equilibrium. Every heartbeat is a defiance of the void, Every thought is a victory over the darkness. We have spent thousands of years clawing our way out of the mud, building civilizations and learning to read the stars, all while the very fabric of reality conspires to extinguish us. This struggle is not a tragedy. It is our greatest triumph. The fact that we exist at all, in a universe so vast and so old, is a miracle that requires no divine intervention to be sacred. If we are truly alone, the stars are not a playground for our ambition, but a heavy and sacred duty. We are the only eyes the universe has to see itself. If we fail, if we allow our flame to go out through our own greed, short-sightedness or violence, then the universe effectively dies with us. The galaxies will continue to spin, and the stars will continue to burn, but there will be no one to name them, no one to wonder at their scale, and no one to understand the laws that govern their birth and death. We are the consciousness of the cosmos, the thin layer of awareness that allows the universe to know that it exists. This is the weight of our lonely responsibility, to keep the light of intelligence alive in a darkness that spans trillions of light years. There will come a time, hundreds of trillions of years from now, when the era of the stars finally draws to a close. One by one, the red dwarfs will exhaust their fuel and fade into black dwarfs, cold, dense spheres of carbon and iron that emit no light and no heat. The nebulae will be depleted, and no new suns will ever ignite. The universe will become a graveyard of cinders, a place of absolute zero where the very atoms of matter may begin to decay. In that far-off twilight, the last star will flicker and die, and the universe will enter a state of eternal cold equilibrium. The memory of our world, of our music, and of our love will be swallowed by the infinite dark, leaving no trace that we ever were. But that end is not our concern. Our concern is the now. Every breath we take is a victory against the infinite dark. Every moment we spend together, every discovery we make, and every act of kindness we perform is a light that pushes back the shadows of entropy. In the face of a silent and indifferent universe, we must look at the person next to us and realize that they are the most precious thing in the entire cosmos. In all the billions of light years of vacuum, in all the quadrillions of tons of gas and dust, there is nothing else like a human being. We are the most complex, the most rare, and the most beautiful thing that the laws of physics have ever produced. The silence of the universe is not a wall, it is a mirror. It reflects back to us the truth of our own significance. We are the ones who give the stars their names. We are the ones who find music in the static of the Big Bang. We are the ones who love in a universe that does not know how to feel. If we are the only heartbeat in this vast cathedral, then every life is an entire universe unto itself, a flicker of warmth that must be protected at all costs. We are the firstborn, the witnesses, and the architects. We are the meaning of the silence, and as long as we continue to look up, the universe is not truly empty. It is simply waiting for us to fill it with our stories.